Hello, welcome back. In the previous video, we discussed the three tables that would make up our car insurance company's database: cars, insurance policies, and drivers. For these three tables to form a database, they must be related. The database must store not just the values, but also the structure, the relationships, and the definition of the meaning of the data. Analogously, the database management system must be able to manage not just the contents, but also the structure, internal relationships, and descriptions of the data. In a relational database, relationships among tables are implemented through the so-called foreign keys. In our simplified example, the cars table could include two additional columns containing special attributes called foreign keys. The insurance policy column would contain, for each car, that is, for each row, the insurance policy code for that car. That must match the primary key of a row in the insurance policy table. Thus, in the cars table, this column or attribute or field would be a foreign key. A key indeed, since it is a primary key in another table, but a foreign, not primary key, since it resides in a different table. The cars table would also contain a second foreign key column, the driving license number for that car's authorized driver. That must also match the primary key of a row in the driver's table. The relational database management system is then able to use these relationships, implemented through foreign keys, to answer queries involving more than one table. An application program could, for example, ask the database management system to compile a table encompassing those cars whose drivers are males aged 30 to 40. That table could also contain the insurance policy's code and its annual fee. Thus, we should now have a better idea of what data structure or data model means in a relational environment. It would include the attributes or fields it encompasses, along with the definition, both in business terms and in terms of formats, such as number versus text versus image. The tables into which these attributes are grouped and the definition. And the relationships among tables through the use of foreign keys. When this data model is described in the formal language of a database management system, it is known as the database schema. It should be noted that the data model or database schema is a key component of a management information system, a la par with its application programs.
This sounds great. I wonder, how could I organize my spare parts stockroom using a relational model?
That is a good question. I'm glad to see that you are warming up to the beauty of the relational model. Unfortunately, you can't implement the relational model directly in a physical warehouse, since it relies on the ability to reconfigure, combine, and present information in different ways. And this is a pity because the relational model provides a number of benefits. The most important benefit is flexibility. As opposed to the hierarchical model discussed before, in which there is a single path to find a given data element, a relational model provides flexibility in how data is accessed and used. Thus, once computers have become powerful enough to properly run relational database management systems, they have nearly replaced the previous hierarchical models. And even though there are also other models using specialized niches, the majority of management information systems in place today contain relational databases. We have discussed in this video the relational model and the attributes organized in tables linked through foreign keys that make up the data model of a relational database, and we have emphasized the importance of this data model as a key component of a management information system. In subsequent videos, we will analyze how a technique called normalization can help us organize data in relational databases, eliminating redundancy, and how application programs interact with the database management system. Thank you. I will see you there.